Hello students, welcome to Yupp Master. This is 11th class IIT Live. I am Radha Krishna, mathematics teacher. Today we are going to discuss a wonderful method in sequences and series, that is method of recursion. We are going to solve problems on method of recursion, and first of all, what is the method of recursion? If a recurrence relation is given between two consecutive terms of a sequence or three consecutive terms or even more, then that is called recursive relation, and we are going to identify the nth term and we are going to find the sum of the terms or product of the terms in case of recurrence relations. Okay, let us discuss the first question. Here first term is given. Usually we denote the first term by T1 or A1, but here first term is given as A0 and any other term is obtained according to this formula. So if you want to nth term, say An, it is 3 into preceding term plus 2. So for example, here A0 is given, so A0 is 1, then you can calculate A1 using this recurrence relation. Alright, it is 3 into 1 plus 2, A1 will be 5. If you take n is equal to 1, A1 is 3 into A0 plus 2, that is 5. Next, A2. A2 is 3 into A1 plus 2. And substituting A1 as 5, you will get 3 into 5, 15 plus 2, 17. Next, A3. A3 is 3 into A2 plus 2. So 3 into 17, 51, 51 plus 2, 53. A4, 3 into 53, that is 159. 159 plus 2, 161, and so on. In this way we can find out any number of terms. Alright. Now how to find An? Here the series starts with A0, so An is n plus 1th term. Alright. Now let us first write the series 1, 5, 17, 53, 53, 161 and so on. Alright. Now what kind of series is this? If you observe the differences, 5 minus 1 is 4, 17 minus 5 is 12, 53 minus 17 is 36 and 161 minus 53 is 108 and so on. Okay. Now you can observe that this is a GP. 4 into 3 is 12, 12 into 3 is 36, 36 into 3 is 108 and so on. These are first order differences. The first order differences are 4, 12, 36, 108 and so on are in GP. Then it is called first order GP. Alright. Therefore, it is a first order GP. Then how to find the nth term of the first order GP? Let us assume that Tn is equal to, we already discussed about first order GP, second order GP, first order AP, second order AP, etc. the nth term of a first order GP will be in the form of a r power n minus 1 plus b. Okay. So, a r power n minus 1 plus b. Alright. What is this r? Common ratio of this last row whose numbers are in GP. What is the common ratio of this GP? 4 into 3, 12, 12 into 3, 36 and so on. So, ratio of any term and the preceding term is 3. So, R is 3. So, take nth term as a into 3 power n minus 1 plus b. Okay. Now, how to find a and b? For finding a and b, we need two equations. We can get those two equations by putting n is equal to 1 and n is equal to 2. Alright. Now, putting n is equal to 1, T1 is equal to a into 3 power 1 minus 1, that is a into 3 power 0 plus b, that is a plus b. What is T1 first term? First term is 1. Alright. Next, T2 second term, putting n is equal to 2 here, you will get a into 3 power 2 minus 1, that is a into 3 plus b, that is 3a plus b, is equal to, what is the second term in this sequence? 5. So, 3a plus b is 5. Then by solving them, subtract these two, you will get 2a is equal to 5 minus 1, 4. So, we get a is equal to 2. But a plus b is 1. So, what is the value of b? B is equal to minus 1. Alright. Therefore, nth term Tn is equal to a into r 3 power n minus 1, 2 into 3 power n minus 1 plus b minus 1. But this is not our answer, because we want to find an, and first term in T1 is denoted by a0, T2 is a1 and so on. So, an will be n plus 1th term. Alright. So, an is equal to Tn plus 1. How do you get? Replacing n by n plus 1 here, you will get 2 into 3 power n minus 1. Alright. This is our answer. Let us go to the next question. If a0 is equal to 4 and an is equal to a n minus 1 plus n, find sum of the terms a1, a2, a3 and so on up to an. Alright, sigma r varies from 1 to n. The recurrence relation is given between an and an minus 1. So, two consecutive terms. So, using this recurrence relation, you can from a0 you can find a1, from a1 you can find a2 and so on. In the previous question, we calculated the terms of the series and then we identified that it was first order GP and calculated the nth term. But here in this question, finding the nth term is required, but we do not need to find the individual terms. Let us see how to find the nth term without actually writing the series. You can write this given relation as an minus an minus 1 is equal to n. Alright. This is true for all n greater than or equal to 1. For all positive integers n. Alright. Now, this is in the form of a general term of a telescoping series. Already we have discussed about telescoping sum. We will write the terms in the form of un minus 1, and on expansion the middle terms will be massively cancelled. Okay. Then you will get the sum of the telescoping series. Since this is in the form of un minus 1, we can apply telescoping series method. Putting n is equal to 1, 2, 3 and so on till n and adding. Alright, what will be the LHS? Putting n is equal to 1, you will get A1 minus A0 plus putting n is equal to 2, you will get A2 minus A1. Next, putting n is equal to 3, A3 minus A2 and so on. Putting n is equal to n, finally it is an minus an minus 1. Alright, this is LHS. Now, in the RHS we have n and putting n is equal to 1, 2, 3 and so on up to n and adding, you will get 1 plus 2 plus 3 plus and so on till n. Alright. Now, left hand side is a telescoping series. We can massively cancel the terms. A1 can be cancelled, A2, A3 and so on. In the last term, an minus 1 will cancel out. Alright. Then LHS is an minus A0. And equal to, what is the RHS? Sum of the first n natural numbers. What is the formula? N into n plus 1 by 2. Alright. Now, A0 is given as 4. So, an minus 4 is equal to n into n plus 1 by 2 and an is n into n plus 1 by 2 plus 4. Alright. We got the nth term. Now, finding the sum of the n terms. Sigma r varies from 1 to n, ar is equal to sigma r varies from 1 to n. If an is this and then ar is r into r plus 1 by 2 plus 4. Alright. R into r plus 1 by 2 plus 4. Now, separate sigma. It is sigma n into n plus 1 by, r into r plus 1 r into r plus 1 by 2 plus sigma 4. In each sigma, r varies from 1 to n. Alright. Now, you take out 1 by 2 and 4 because they are constants. You will get 1 by 2 sigma r into r plus 1. R varies from 1 to n plus this is 4 sigma 1 r varies from 1 to n. And what is this sum? Already I have given a formula for you. Sigma n into n plus 1 is nth term into next factor n plus 2 by number of factors in the numerator 3. And sigma r into r plus 1, where r varies from 1 to n, is same as sigma n into n plus 1. Alright. Then this is n into n plus 1 into n plus 2 by 3 into 1 by 2. It will be by 6 plus 4 into sigma 1 is n. We should add 1 n times for r is equal to 1, for r is equal to 2, r is equal to 3, up to r is equal to 1, for r is equal to n. For each r we have to add 1. So, you have to add 1 n times. So, sigma 1 is n. Alright. So, this is our answer. Okay. Let us proceed to the next question. A1 is 2 and relation between an and an minus 1 is given like this, relation between two consecutive terms. In this question also, we do not need to find the terms of the series. Okay. Now, in the earlier question, because it was, this is in the form of a telescopic relation, nth term of a telescopic relation, we used telescoping series summation. Alright. In this case, an is n plus 1 into an minus 1. So, taking an minus 1 to left hand side, an by an minus 1 is n plus 1. Alright. Now, since ratio is there, ratio of two consecutive terms is there, here we are going to follow telescoping series product form or telescoping product. We can write this as a telescoping product. What is telescoping product? If you write nth term and n minus 1th term as a ratio and substituting n is equal to 1, 2, 3 and so on and multiplying, all terms will be massively cancelled except one term or one or two terms in numerator and one or two terms in denominator, and we have already solved one question in the previous classes. Alright. So, what we are going to do is putting n is equal to, here if you put n is equal to 1, denominator is a0 is not there. So, we will start with n is equal to 2, 2, 3, 4, 5 and so on till n. Putting n is equal to 2, 3, 4, 5 and so on till n, and what should we do? Multiply and multiplying. Alright. What will you get in the LHS? Putting n is equal to 2, you will get a2 by a1 into, putting n is equal to 3, a3 by a2, putting n is equal to 4, a4 by a3, next a5 by a4 and so on. Finally, putting n is equal to n, you will get an by an minus 1. This is LHS. In the same way, in the RHS also we have to put n is equal to 2, 3, 4 and so on till n and multiply. Putting n is equal to 2, you will get 3. Putting n is equal to 3, you will get 4. Next 5, 6 and so on. Putting n is equal to n, you will get last factor as n plus 1. Alright. Now, look at the LHS. It is a telescoping product and terms can be cancelled massively like this. A2 cancels diagonally, A3 also cancels, A4 also cancels, A5 also cancels. In the last term, denominator will cancel out. So, only last factor of the numerator and first factor of the denominator are remaining. Alright. Now, an by a1 is equal to, in the RHS, we know that product of consecutive natural numbers starting from 1 up to n is n factorial, but this started with 3. So, to write it in the short form, n factorial form, we will multiply by 1 and 2 and divide by 1 and 2. Alright. Now, 1 into 2 into 3 into 4 into and so on up to n plus 1 can be written as n plus 1 factorial. This is the notation for factorial, n plus 1 factorial. By 1 into 2 is 2. Alright. And a1 is 2. So, denominators will cancel. So, we got an as n plus 1 factorial. Alright. Now, the next question. Let an be a sequence of non-negative real numbers such that an is equal to square root of an minus 1 plus 1 by 2 and a1 is given as 0, then find an. See, in the earlier questions, in one question we expressed the difference of consecutive terms as something and we used telescoping summation, and in another question ratio of consecutive terms is given, so we use telescoping product, but we cannot apply any of those techniques here because of the square root. Okay. Then multiplication or addition, nothing will work. In this question we are going to use a new technique, that is substitution method. We will substitute an minus 1 as something so that this will be in the form of an minus 1 only. What substitution? If you closely observe the relation between an and an minus 1, it looks like a formula. We have already discussed that formula in the previous classes in trigonometry. Okay. What is that formula? We know that cos theta plus 1 or 1 plus cos theta is 2 cos square theta by 2. All of you are aware of this formula. So, cos theta plus 1 by 2 is cos square theta by 2. Alright. Now, taking square root on both sides, cos theta by 2 will be root over cos theta plus 1 by 2. Now, the relation between an and an minus 1 is exactly in this form, and an minus 1 and an are in a similar pattern, both are cos. Alright. So, let us go for this substitution. If an minus 1 is cos theta, okay, then an is equal to square root of cos theta plus 1 by 2. What is it? Cos theta by 2. So, if a term of the series is expressed as cos theta, then immediately next term will be cos of that angle theta by 2. Suppose you want an plus 1, it will be cos theta by 2 square, an plus 2, cos theta by 2 cube. So, in this way we can write the entire series. Alright. But for developing the series, we need first term. First term is given, a1 is given as 0. Alright. Now, let us write a1 in the form of cos theta. How can you write? Cos of how much a1 is given as 0. So, a1 is 0, we can write it as cos of how much? Cos pi by 2 is 0. So, write a1 as cos pi by 2. Then, what is a2? a2 will be, according to this, if an minus 1 is, if previous term is cos theta, the next term will be cos theta by 2. So, if a1 is cos pi by 2, a2 will be cos pi by 2 square. Then a3 will be cos pi by 2 cube, and a4 cos pi by 2 power 4 and so on. Then what will be an? An will be cos of pi by 2 power n. Alright. Now, proceeding to next question. The classical Fibonacci sequence is defined as f1 is equal to f2 is equal to 1, and thereafter fn plus 2 is equal to fn plus 1 plus fn for all natural numbers n, and then evaluate the summation 1 by fn minus 1 into fn plus 1, where n varies from 2 to infinity. And all of you must be familiar with Fibonacci sequence. A Fibonacci sequence is a sequence in which every term is sum of the previous two terms. Okay, sum of the preceding two terms. So, n plus 2th term is n plus 1th term plus nth term. These two are preceding terms now. Okay. Here, first term and second term are given. Because of this relation, we can write that Fibonacci sequence only when two terms are given. So, first term and second term are equal to 1. So, 1 comma 1. What will be the third term? Third term will be sum of the first two terms, that is 2, 1 plus 1, 2. And what is the next term? It is the sum of second and third terms. How much? 1 plus 2, 3. Next term will be 2 plus 3, 5. Next term will be 3 plus 5, 8. Next is 5 plus 8, 13. Next is 8 plus 13, 21. Next is 34, and so on. You can continue till any number of terms. This sequence is called Fibonacci sequence. And if you take first two terms as 1 and 1, it is classical Fibonacci sequence. Alright. Now, we have to find this summation. For finding this summation, let us write it on the next page. Sigma 1 by f n minus 1 f n plus 1, n varies from 2 to infinity. Actually, you are aware that sum of the infinite series cannot be calculated directly. First we have to find sum of the n terms, then taking n as infinity, we will find sum of the series up to infinity. Alright. So, I am going to find the sum up to n terms. Let us denote it by Sn. And what is the relation between fn minus 1 and fn plus 1? We have to observe. This is the relation for any value of n. You can replace n by anything. So, replacing n by n minus 1 on both sides, what we will get? Fn plus 2 becomes fn plus 1 is equal to fn plus 1 becomes fn, replacing n by n minus 1, plus fn becomes fn minus 1. Alright. Now, the relation between fn minus 1 and fn plus 1 we want. Taking fn minus 1 this side, you will get fn plus 1 minus fn minus 1 is equal to fn. Alright. So, if you can write the numerator as difference of the factors of denominator, then by separating we can get something like a telescoping series. But numerator is 1. If it is fn, you can write it as difference of the factors of denominator. So, you should realize that we need to multiply and divide by fn. Multiply by fn and divide by fn. Fn minus 1, fn, fn plus 1. N varies from 2 to n. Alright. Now, write this fn as fn plus 1 minus fn minus 1. By fn minus 1 fn fn plus 1, n varies from 2 to n. Alright. Now let us separate the denominator. Separating the denominator, this by this is fn plus 1 cancels. You will get 1 by fn minus 1 fn minus fn minus 1 by the denominator will be 1 by fn into fn plus 1. Alright. Now clearly it is in the form of nth term of a telescoping series. If n is replaced by n minus 1 here, you are getting this. So you can take it as un minus 1 minus un. So expanding the sigma, we will get a telescoping series. So putting n is equal to 2, 3, 4 up to n. Putting n is equal to 2, it will be 1 by f1 into f2 minus 1 by f2 into f3 plus putting n is equal to 3, 1 by f2 into f3 minus 1 by f3 into f4 plus putting n is equal to 2, 3, 4, 1 by f3 into f4 minus 1 by f4 into f5 and so on till nth term. Putting n is equal to n, you will get 1 by fn minus 1 fn minus 1 by fn into fn plus 1. Alright. Now it is a telescoping series. You cancel the middle terms. 1 by f2 into f3 cancels. 1 by f3 into f4 cancels. Next this cancels. In the last term, first part will cancel out. Alright. Then it is equal to the values of f1 and f2 are given. f1 is 1, f2 is 1. So 1 by 1 is 1 minus 1 by fn into fn plus 1. Alright. Now we can calculate the sum up to infinity. S infinity we want. S infinity is equal to, if you observe the series, the terms are increasing massively. So when you go to infinity, the last terms will be very, very large. So we can take the last terms as infinity. If n tends to infinity, fn tends to infinity, fn plus 1 also tends to infinity. Then what is 1 by fn into fn plus 1? 1 by infinity into infinity, which tends to 0. Alright. So S infinity will be equal to 1 minus 0. Answer is 1. Alright. Now next question. And this is a wonderful question, and you need to learn so many things from this question. Okay. So let us have a long discussion on this question. T1 is given, T2 is given. Okay. Two consecutive terms, first two terms are given, and relation between three consecutive terms are given. And how you get n plus 2th term from n plus 1th term and nth term is given by this relation. Alright. Now the given relation is t n plus 2 is equal to 5t n plus 1 minus 6tn. Alright. Then this is true for any value of n. This is for all n greater than or equal to 3, because already first two terms are given. So it is true for all natural numbers greater than or equal to 3. Alright. Now if I replace n by n plus 1, it will be true. Tn plus 3 will be equal to 5Tn plus 2 minus 6Tn plus 1, replacing n by n plus 1 on both sides. Again, if you replace n by n plus 1, it becomes Tn plus 4 is equal to 5 into Tn plus 3 minus 6Tn plus 2. Again, replacing n by n plus 1, you will get Tn plus 5 is equal to 5Tn plus 4 minus 6Tn plus 3, and so on. Now, if you observe these relations, you can easily guess what kind of term Tn is. If you take a power n plus 2 is equal to 5 a power n plus 1 minus 6 a power n, if you consider this relation, multiplying both sides by a, it becomes a power n plus 3 is equal to 5 a power n plus 2 minus 6 a power n plus 1, multiplying both sides by a, and multiplying again by a power n plus 4 is equal to 5 a power n plus 3 minus 6 a power n plus 2. Again, multiplying both sides by a power n plus 5 is equal to 5 a power n plus 4 minus 6 a power n plus 3, and so on. Observe that these relations are in the same form of these relations. So, you can guess the nth term Tn as a power n. Okay. Therefore, Tn is equal to a power n. Alright. Now, in this connection, I would like to tell you one important general point. Whenever the relation between three consecutive terms in a sequence is a linear relation in the three consecutive terms, then the nth term will be in the form of a power n. What is a linear relation? See, we can write this as Tn plus 2 minus 5Tn plus 1 plus 6Tn is equal to 0. If the relation between Tn plus 2, Tn plus 1, Tn is in the form of a into Tn plus 2 plus some constant b into Tn plus 1 plus another constant c into Tn is equal to 0, where a, b, c are constants independent of n, then this is called a linear relation between Tn, Tn plus 1 and Tn plus 2. Okay. So, all of you make a note of it. If the relation between three consecutive terms of a sequence is a linear equation then the nth term will be in the form of a power n. Then the nth term will be a power n. Alright, remember this point. Okay. Now, how to find A? To find A, substitute Tn is equal to A power n in the given equation. What is the given equation? Tn plus 2 is equal to 5Tn plus 1 minus 6Tn. Substituting Tn is equal to A power n. If Tn is A power n, Tn plus 2 will be A power n plus 2 is equal to 5 A power n plus 1 minus 6 A power n. Alright. Now, you can write A power n plus 2 as A power n into A square is equal to 5 into A power n plus 1 is A power n into A minus 6 into A power n. Alright. We can cancel A power n on both sides because A power n is never 0. So, cancelling A power n, we get A square is equal to 5A minus 6. Alright. Then A square minus 5A plus 6 is equal to 0. Right. This is a quadratic equation. It will have two roots. Let us find them. You can easily factorize it as A minus 2 into A minus 3 is equal to 0. So, we will get A is equal to 2 or 3. So, is the answer 2 power n or 3 power n? Let us check. If we take 2 power n or 3 power n, if Tn is 2 power n or 3 power n, what happens? Check these two. T1 is 0. What is T1 here? If it is 2 power n, T1 is 2. If it is 3 power n, T1 is 3. Not satisfied. Similarly, what is that? T2. T2 cannot be minus 6 in these two cases. Then, is this answer wrong or the given information in the question is wrong? Here, it can be a combination of 2 power n and 3 power n. Nth term Tn can be a combination of 2 power n, 3 power n. So, let us assume that let Tn be equal to some constant k1 into 2 power n plus another constant k2 into 3 power n. Okay. Now, we have to find the constants k1 and k2 satisfying these two conditions. Alright. So, let us substitute n is equal to 1. T1, putting n is equal to 1, what will you get here? 2k1 plus 3k2 is, what is T1 given? 0. And T2, putting n is equal to 2, k1 into 2 square is 4k1 plus k2 into 3 square is 9k2 is equal to how much? Minus 6. Now, let us solve. Multiplying the first equation by 3 and subtracting second equation, k2 will cancel out. So, multiplying first equation by 3, 3 into 2, 6k1 plus 9k2 is equal to 0 into 3 is 0. Second equation is 4k1 plus 9k2 is equal to minus 6. Subtract. K2 will cancel. 6k1 minus 4k1 is 2k1 is equal to 0 minus of minus 6 is plus 6. Then k1 is equal to 3. Alright. Then substituting k1 in any one of the equations, you will get k2 is equal to minus 2. Therefore, the nth term is Tn is equal to, Tn is k1 2 power n plus k2 3 power n. No? K1 is 3, so 3 into 2 power n minus 2 into 3 power n. Understood? So this is called solution of the recurrence relation. So solving a recurrence relation means finding the nth term using the recurrence relation. Alright. And I would like to give you some more important points here. Here, whenever the relation between three consecutive terms is a linear relation, linear equation, then the nth term is going to be a power n. That point is here. Okay. Then putting a power n in place of Tn, then definitely you will get a quadratic equation. You will get a quadratic equation like this. This quadratic equation is called characteristic equation of that recurrence relation. It is called characteristic equation of the recurrence relation. Alright. And the roots of the characteristic equation, these are called characteristic roots. Alright. Now, if the characteristic roots are some alpha and beta, you should take the nth term as k1 into alpha power n plus k2 into beta power n. Alright. Now, if the relation between four consecutive terms is given as a linear equation, just like this, then the nth term will be definitely of the form a power n. Then substituting a power n in the linear equation for four consecutive numbers, you are going to get a cubic equation. When the relation between four consecutive terms is given, then you are going to get a cubic equation as characteristic equation. Then you will get three characteristic roots. Alright. Then for finding when you get three characteristic roots, say alpha, beta, gamma, we should take the nth term as k1 into alpha power n plus k2 into beta power n plus k3 into gamma power n. For finding the constants k1, k2, k3, we need three consecutive terms. Usually first three consecutive terms will be given. You can find the constants by solving the equations by putting n is equal to 1, 2, 3. We need three equations for finding k1, k2, k3. Putting n is equal to 1, 2, 3, we will get three equations in k1, k2, k3, then solve. For example, let us take one question. Solve Tn plus 2 minus 6t, not n plus 2, n plus 3, 4 consecutive terms, no? Tn plus 3 minus 6t n plus 2 plus 11t n plus 1 minus 6 Tn is equal to 0. This is the recurrence relation. Okay. Now, how to solve? Immediately, since it is a linear equation, we will take Tn as a power n. Then substituting a power n, this becomes a power n plus 3 minus 6 a power n plus 2 plus 11 a power n plus 1 minus 6 a power n is equal to 0. You can cancel a power n on both sides. Then you will get the cubic equation a cube minus 6a square plus 11a minus 6 is equal to 0. It is called characteristic equation of the recurrence relation, and if you solve, you will get factors a minus 1 into a minus 2 into a minus 3 is equal to 0. We will get characteristic roots as 1, 2, 3. Then the nth term will be some constant k1 into 1 power n, 1 power n is 1, plus another constant k2 into 2 power n, plus k3 into 3 power n, alright. And for finding k1, k2, k3 we need 3 consecutive terms. If t1, t2, t3 are given, we can find k1, k2, k3, alright. Now let us proceed to next question. If an is equal to 6an minus 1 minus 9an minus 2, a1 is given, a2 is given. Relation between 3 consecutive terms is given, and it is a linear relation. Linear relation between an minus 1 and an minus 2 is given, and 2 consecutive terms are given. We have to find an. An minus 6 an minus 1 plus 9 an minus 2 is 0. Since it is a linear equation in an minus 1, an minus 2, nth term an can be taken as a power n. Since this is a linear equation, an nth term can be taken as some constant a power n. Okay. Now substituting a power n in the given equation, we will get a power n minus 6 a power n minus 1 plus 9 a n minus 2 is equal to 0. Sorry, a power n minus 2. Is equal to 0. Alright. Now you can cancel a power n minus 2 on both sides. Cancelling a power n minus 2, you will get a square minus 6a plus 9 is equal to 0, which is the characteristic equation of this recurrence relation. Then what are the roots? This is clearly a perfect square. A minus 3 whole square is equal to 0. A minus 3 whole square is equal to 0. Then we get a is equal to 3 comma 3. There are two roots, but they are equal. When you get repeated roots like this, how to take the nth term? In the earlier question there were different roots 2 and 3. So we took k1 into 2 power n plus k2 into 3 power n. But here will you take k1 into 3 power n plus k2 into 3 power n? That is going to be some constant k into 3 power n. No, we have to take nth term as, when you get repeated root, we have to take nth term as k1n plus k2, one linear term in n, first degree term in n, into 3 power n. Alright. Similarly, suppose the characteristic equation is a cubic equation. Then you will get 3 roots. Suppose all the 3 roots are equal. you got 2, 2, 2 as characteristic roots. Then what will be the nth term? We should take nth term as a quadratic expression in n, k1n square plus k2n plus k3 into, if the root is the repeated root is 2, into 2 power n. We should take the nth term like this. Understood? So if the root repeats 2 times, you take that root power n into one linear term, first degree term. If the root repeats 3 times, then you take it as quadratic in n into 2 power n. Alright. So in this question, we have to find k1 and k2 using the a1 and a2. Putting n is equal to 1, a1 is equal to k1 plus k2 into 3 is given as 9. Alright. So dividing by 3, k1 plus k2 is equal to 3. Putting n is equal to 2, a2 is equal to 2k1 plus k2 into 3 square. 3 square is 9 and a2 is given as 36. Alright. Then cancelling 9, we will get 2k1 plus k2 is equal to 4. Alright. Now solving 2k1 plus k2 is equal to 4 and k1 plus k2 is equal to 3. Just by direct subtracting, we will get k1 is equal to 4 minus 3, 1. And substituting k1 is equal to 1 in the first equation, we get k2 is equal to 2. Alright. Then what will be the nth term? an. It is k1 is 1 now, so n plus 2 into 3 power n. This is an, nth term of the sequence. Alright. So today we have discussed wonderful methods in solving recurrence relations, and in the next class we are going to discuss inequalities. After the inequalities, we are going to solve some miscellaneous problems and some previous JEE mains and advanced questions, and then only we are going to go to next topic. We are going to start coordinate geometry after this chapter. Alright. So see you in the next class.